Okay, guys, welcome back. Here's our new lesson, our new unit of material, functions and relations. Okay, I'm going to do this all together, put the functions and relations and evaluating functions. It looks like a long lesson, but that's just because the examples, there's some word problems mixed in there as well. So I would highly encourage you. I print out the PowerPoint slides for my students in class, so that way they don't have a lot to write. But it's up to you. If you want to write in your notebook, you can. Just try and write the highlights of what you need and the examples. Okay, so remember, this notebook is for you for the future. So whatever you think is necessary, please write down. So we identified domains and ranges for given situations. You did that back in Algebra 1. We're going to review those still. Now we're going to analyze relations and functions and then use equations of relations and functions. Okay? Some vocab, there's a lot. Okay? So we're going to talk about specific types of functions. One-to-one, on-to. We're going to talk about different types of relations, discrete and continuous. We'll talk about the vertical line test, which should sound familiar, and function notation. Okay, we'll go back through a little bit of that at the very end of this lesson. Okay, so some vocab. The domain is all the possible input values a function can have. Okay, an easy way to remember, if you look at an XY table, domain are the X values. Okay, the range are the Y values, which we know is the output. Okay, haven't talked about what a function is yet. We'll get to it. But domain is your X values, your range are your Y values, your input, your output. Okay, and then a relation is just a set of ordered pairs. Okay, and what do I mean by ordered pairs? Because there's a lot of vocab I'm throwing at you. Okay, a relation could just be something like this. Okay, this is a relation, just ordered pairs, X and Y pairs. I can plot those, right? That's going to be 3 points on a grid. So that's just a relation. Now, is there specific types of relations out there? Yeah, we're going to get to that. So let's look at a solid example first. Let's talk about it. This is the monthly average temperatures in Fahrenheit from North Carolina, Charlotte. Okay? Now, if you take a look, we have the months of January all the way to December. Okay? So right now, let's see, we're in October. Today's the 1st of October. It is when I'm recording the video. I don't know when it will be when you watch it. So their low is 51 degrees. Their average high is 73 degrees. Okay? Sounds about right where we are at. Can't talk. At the end of the day, it's so hard to talk anymore. Okay, taking a look at this table, we could say that all the lows would be like an X value for us. So let's look at 32 degrees as my X value. My high value for the month of January could be my output. We'll say 51 degrees. Okay, we can have a low and high for a grid, just for instance. Now take a look at everything. Do you see in this grid, okay, do you see any outputs that are repeated? I don't think so, right? I think all the highs are different numbers. I don't see anything repeated. We might have some lows that are repeated, huh? I think March, the average row is 42 degrees. This average low is 42 degrees. So there's some repeats there, okay? But if you imagine this on a grid, and I was just plotting points, okay? This is a relation, okay? It's all these points put together. And then we're going to analyze what that could be. So this is like a real-world example of what could domain and range of functions be. And we'll get back to that in this lesson. So we say the word function a lot. What does it mean? It's a type of relation, okay, in which each element in the domain, so each X value in my domain, is paired up with exactly one element in the range. It's a partnering thing, okay? That's what it is. That's what a function is. So if you notice, see how every X value in this relation has a partner? It's partnered up with a Y value. So this could be a function. This is a function. Okay. Now, think of it this way. Not a function. And I know that's not on the screen, but let's talk about it. So if a function has each element paired up with see, I told you I can't talk. Exactly one element in the range, it has to be the opposite to be not a function. So that means let's say this is my relation. My domain of 1, my x value 1, has two different partners here, 2 and 4. So they're not paired up with exactly 1. So this would be not a function. Okay, it goes against the definition. I think a lot of times when we talk about words, we talk about vocabulary and mathematics, sometimes the definition doesn't resonate with people. So just putting an example like this, I think, does a better job with it. Okay? So here's the types of functions we can have, given that they satisfy what a function is. Here are mappings to show that. So it's a nice visual so you can see this. So domains like my x values, my range, or my y values. I just put them in bubbles and drew arrows to connect them. Okay? So you could have a one-to-one function. Each element in the domain pairs up to one unique, that's important, unique element in the range. Okay? Not everything was selected, and that's okay. As long as these guys are not partnered up with more than one y value. Okay, then it's not a function. So that's one-to-one. An onto function, each element of the range corresponds to an element in the domain. So notice how, look at 3 and 4. They both have C in their range. That's okay. That's allowed. But notice, every range value has a partner or partners, okay? They're all picked. That's a good thing. See how one-to-one, not everyone was picked? This one, it's the opposite. Everyone is picked, okay? Last one, you could be both one-to-one and onto. And look at the visual here, okay? Each element of the domain is paired to one element in the range, exactly one, okay? So everything's unique, as you can see by the mapping here. Okay, every x value here is going to match up with every y value on the other side. Okay, so these are the types of functions that we could have here. Questions? No? Okay, no questions. Let's keep going. Domain and ranges. Okay, start with a basic example. State the domain and range of this relation. Then determine if it's a function, and then what type of function. Is it one-to-one, onto, both, or neither? Okay. Well, my domain, I'm going to list all my elements in domain, and I'm going to use a set notation here. My domain are all the x values. So let's see, I have -4, -3, 0, 1, and 3. Okay, my range would be the y values. So let's see, I got -2, 0, 1, 2, and 3. There's my domain, there's my ranges. Listed them in the set notation form. Just brackets. Now, is this a function? Well, think about it. Is there an x value that has more than one y value? I don't think so. -4 is only paired up with 0. I don't see another -4 on the list. -3, there's only one -3 as an x value on here, and it's partnered up with 1. And if you keep going through all the other ones, you're going to get the same thing. So I want to say that this is a function. Okay? So we're going to say yes, it's a function. Okay? Now the real question is it one-to-one, onto, or both? Well, if you don't remember, one-to-one means that everything in the range is partnered up with a unique y value, right? Or with an x value, and it is. Okay, onto means that every y value was picked, and it has to be because we got x, y pairs. So I'm thinking this is both. So this is both onto and 1, 2, 1. Okay. Now, let's say you couldn't do this just by going through a list in your head. What you could do is put together a mapping. Okay. -4, -3, 0, 1, and 3. -2, 0, 1, 2, and 3. And with the mapping, just draw arrows. -4 goes to 0. -3 goes to 1. 0 goes to -2. 1 goes to 2. And 3 goes to 3. Look at the mapping. Okay, based on the mapping, is it onto? Yeah, every y value is picked, so it is onto. That's the easiest one to figure out first. If every y value is picked, so I'll put that next to it. Every y value is picked. Okay, that's what makes it onto. Okay, is it 1 to 1? Meaning, is every, or I don't want to say every, is each y value, or how can I word that? I want to word this right. How do I want to say this? Is an x value paired with one y value? And it is, right? Every x value is paired up with a y value. Okay? Meaning a y value isn't picked twice. Okay? So let's go back to this guy. Unlike an onto function, you see how they could, like this guy got picked by 2 different inputs. Okay, this guy didn't. Everything was unique. Okay, it's still onto because everything was picked. That's the satisfying part. But it's 1 to 1 because everything is unique. Okay, like -2 wasn't picked by 2 x values. Okay. Sorry, in my mind, I'm like, what's a good way of writing it? And honestly, looking at the picture is a better way than writing it sometimes. Okay, sorry that took a little longer, but I wanted just to establish what each thing meant. So think about this one. Okay. State the domain and range, and is this relation a function? Okay. Well, let's take a look. My domain was -3, 0, 2, and 3. It's the x values. So it looks like B and D have that domain. And they have the same range values too, right? -1, -2, 0, and 1. So B says it is a function, D says it's not a function. So we got a 50-50 shot. In this case, it will be a function, right? Okay? There's not an x value in there that has 2 different y values. So we're good. So it has to be B for that guy. Try another example. Determine the domain and range, and then describe the table as it relates to functions. So we're going to describe, what is it? 1 to 1 or onto. Look at the first table. I tried to color code it. Make it a little easier to see, maybe. If you're colorblind, I don't know, maybe not. So here's my x's, here's my y's. So what's my domain and range? Well, you can write on here. This is your domain, all the x's, range is all the y's. Same thing down here. That was easy. Okay, is it a function or not? For the first one, I'm going to say no, not a function. Can you see why? Right here. -1, the input, has 2 different outputs. Not a function, not going to work. Okay? So that one's gone. So I don't have to worry about that one no more. Down here, is this guy a function? Yeah. Every x value is different, and they're partnered up with the y value. that's good, unlike the first one. Now, is it one-to-one? Is it onto, or both? Well, it's onto because every y value is picked, right? That's what onto means. Think of it as a piece of paper. If you're going to fold a piece of paper onto itself, see? It fits perfectly, right? Edge to edge, crease to crease, so forth, okay? That's what onto is. Everything lines up. Everything has a partner. Everything has, corners and corners go together. So it is an onto. Isn't one-to-one, meaning that there's not a y value here duplicated twice. Like it's not being used twice. There isn't. Every y value is different. So this would be both. So this is both an onto and one-to-one. Okay? All right, let's go back to relations now. Okay? We could have so let's recap. I don't want to seem like I'm going too fast. We have a normal relation, which is just a set of points, right? It's a function if every x value is paired up with a unique y value, okay? And none of the x values are duplicated to where they have different y values. So we're good there. Now we're going to say a relation can be described as discrete or continuous. Those are my next two adjectives I'm going to use. A discrete relation, okay, is just a set of individual points. That's it. Okay? So like the points I gave at the beginning of this lesson, or if you go back to the chart of the weather points, the temperature points, that's discrete. Continuous is a relation that has an infinite number of elements. Okay? So a good example is a line. Okay? This would be a continuous relation. It goes on forever. It's infinite. Okay? If I just have points, and notice they're not connected, okay, this would be discrete. Okay? Just points are listed. I didn't connect them, just points. Okay? All right. Vertical line test. You've probably heard of this one before. Okay, a vertical line test will tell you if it's a function or not. It's a quick way of knowing this. Okay? So look at this parabola right here, this quadratic. If I draw a vertical line anywhere on this parabola, it only intersects the graph once. If that's the case, we can call this a function. So it's a visual thing. So if you graph your relation, you can see if it's a function or not. Now look at this guy. Because the vertical line test hits the graph twice, not a function. Why? That's important. Why is this such a no-no? Why is this bad? Well, think of it this way. Let's say this x value is 3. Well, my input has two different outputs, right? Let's say this is -4 and this is 3. So I have 2 points here. Okay? And notice the input 3 gives me two different output values. So this is not a function because of that. Okay? So that's why the vertical line test tells us if it's a function or not. It's because we're looking at the coordinate points. But that's an easier way of doing it. Okay? So if they give you a graph, draw vertical lines. Okay? You can tell if it's a function or not. All right, transportation. Now this is where I say don't write everything down. You can write this stuff down. I highly encourage you to print out the PowerPoint slides. Okay? So before I give you the answer, pause it, read it, try it out for yourself. So it says here, the table shows the average fuel efficiency in miles per gallon for SUVs for several years. Graph the information, determine if it represents a function. Is this relation discrete or continuous? Okay? So first off, is this even a function? Well, my inputs are the years. My output is the fuel efficiency, right? Okay, if I take a look at this. So notice, 2001, 2, all the way to 7. Do you see any of those years being duplicated? No. So it's a function then. I don't have to worry about that. Okay. Is this relation discrete or continuous? Well, right now, we just have data points. We don't have an equation that says a trajectory of where it's going to go. So this is discrete. Okay, it's not like a line. I'm not continually graphing this stuff. Each year, I'm just putting a data point there. Okay, and it can change. So it's not continuous. All right, let's take a look at the graph. So here's the vertical line test that you can try out. And you could, if you want to connect some of these dots, you can, but just be careful. Remember, this is discrete. So I would leave it as such, but if I drew a vertical line through this point here, it doesn't hit another data point, right? Same thing with the other ones. If I drew vertical lines through these data points, it's only hitting one point, okay? And since that's the case, this is going to be a function, okay? Let's try another one. So we have a table that shows the average weight of a baby for several months during the first year. Graph this information and determine if it represents a function. Okay. So first off, is this relation a function? Answer is yes. If you look at the age, each age shows up once. I don't have age 1 showing up another time with a different average weight. So this is a function. Okay. If we graph this, we should see that it's still a function. So look at the options here and tell me which one it would be. Well, looking at the data table and plotting the points correctly, okay, you should get the answer as A. Okay, A represents the data points correctly. It is a function. If I draw a vertical line, it only hits one data point, not more. Let's go further. Would that be discrete or continuous? Be discrete, right? It's not continuous. Okay, we're not showing a trajectory. We're not drawing a line through all those points. Okay? We're not trying to find the best fit line. That's a different topic altogether. So that would be a discrete type of function. Or relation, sorry. Okay. I think this one is going to be the last one, and then we're going to jump into evaluate to finish this up. So graph the following: y equals 3x minus 1, determine domain and range, and then determine if the equation is a function one-to-one onto both or neither, and then state if it's discrete or continuous. Wow. That's a lot. But we can do this. I know we can do this. I feel you guys cheer me on. Hopefully you are. Okay, so here's my graph. We'll just do a rough sketch. Intercepts at -1, and then we're going to go up 3 over 1. There we go. Okay, told you it's going to be a rough graph. First things first, is this a function? Yes. Okay. Anywhere I draw a vertical line, it intercepts the graph once, which means there are no duplicate x values here. Okay, it's a good thing. Passes that. Is it one-to-one onto or both? Well, is every y value on this grid being used? Yes. So it's onto. Every y value is being used. Is it one-to-one? Do we have a unique y value for each x? Yes. Okay, there's not two different x values that have the same y value. So it would be both. So this is both one-to-one, and it's onto. Okay? Is this relation? Remember, relations all these data points, and there's an infinite number here. Is it discrete or continuous? This is continuous because it goes on forever, right? That's what these arrows indicate, and we know when we graph a line, it's continuous. It's infinite. So this is a continuous relation. So Goofy head, I'm sorry. Told you, it's the end of the day. Can't talk. Getting tired. Hopefully you're not at home. Hopefully you're doing well. Okay? Alrighty. So, oh, you know what we didn't do? Domain and range. You didn't tell me to find domain and range. Come on, guys. You gotta yell at your TV screen, your computer monitor, wherever you're watching it. You're supposed to tell me, hey, domain and range. The domain, what are all the x values we can have here? It's infinite, right? It's all real numbers. So all real numbers. Okay? I'll use the symbol just to abbreviate. My range would be all real numbers because once again, I'm hitting every y value up there, right? So they're both infinite. So all real numbers for both. Okay? When we talk about piecewise functions, which is in a future lesson, it's not going to be all real numbers. Okay? When it comes to continuous graphs, we're going to do something different for that. Okay. So let's jump to evaluating functions, and this will be it. This will be our grand finale. And this should look a little bit familiar. I hope it is. Don't mind the other noise that you hear outside in the hall. I don't know if you can hear them outside, but as you can tell, my classroom's not soundproof. Not by any means necessary. So how do we evaluate a function? Well, let me take a step back. To this point, you were given equations that look like this. Y equals, told you I can't write. Y equals x to the third minus 3. Okay? Instead of writing y equals, I wrote f of x. That's what this reads as. This is f of x. That's how you talk when you read this, f of x. Okay? The reason why I switch it to this notation is because this is a function. I'm telling you already that this satisfies a function. That's all this is. A lot of people get confused with that when they see this guy. It's just like y
Can I have your attention, please? If James Huggins is still in the building, please come to the main office. James Huggins to the main office. Thank you.
Okay. Sorry, interruption there. But hey, it makes you feel like a part of the class. So all this is a notation. This is just telling me it's a function. Now, look at what this is. This is the equation. Okay, that didn't change. It wants you to find, f of negative 2. So this reads f of negative 2. It's substitution. If I did x equals negative 2, if I wrote it like that, wouldn't you be plugging negative 2 into here and solving? You would, right? So that's what this is telling me. Plug negative 2 in for x, and then simplify. So that's what this means. I think a lot of times people get confused with that notation. So when I say f of negative 2, I'm going to plug that anywhere I see an x. So negative 2 cubed minus 3. And please, when you're solving this in your homework, write it like this. Get used to using this notation. Okay? So f of negative 2 equals negative 2 cubed. Okay, that'd be what? Negative 8. 2 times 2 is 4. 4 times 2 is 8. Minus 3. So f of negative 2 is negative 11. That's my final answer. Okay? Now, once again, when people see this, I get students who are confused by that. Okay? This is what this is. If you plug in x is negative 2, the output is y equals negative 11. It's an xy table in a way, okay? But that's what this is. That's what this means. You give me negative 2, the output's negative 11. Getting all kinds of interruptions in this video. Hopefully that makes sense, okay? All right, let's try another one. Find f of 2t. Now I'm going to erase this. let's think about this for a second. This is a function. This graph or this relation is a function, right? That's what that means. This is telling me to plug 2t in for x. I'm plugging another variable in there. Kind of awkward, but let's try it out. So anywhere I see an x, I'm putting this whole thing in there. Okay? So it'll be 2t cubed minus 3. Now let's continue. Let's evaluate. 2t cubed. Now, each part of this is getting cubed. 2 cubed is 8. T to the third is just t to the third. Okay? Minus 3. Can I simplify that any further? No, I'm done. I can't go any further. Usually when you have a variable that you're plugging in for another variable, you're going to get an expression at the end. You're not going to get like a solid number. Okay? In rare cases, you might. It depends on what the equation is. You might have variables cancel, but in this case, it didn't. So that's as far as I can go with it. Okay? Last one. F of negative 1. And let me write the whole thing. I really hope you can't hear all that conversation out there. Okay, so this is telling me to plug negative 1 in for x. Remember, this is like substitution. These literally mean the same thing. I'm just using a function notation because I'm telling the person, the math person, that, hey, this is a function, okay? That's what it's telling me. And if it's a function, that can help me interpret this even further. Okay, so f of negative 1 equals negative 1 squared plus 5. So this gets plugged into this guy. Let's continue. Negative 1 squared is 1 plus 5. Add them together, we get 6 as our final answer. So my option is going to be D. Okay? Just like that. Remember, this is like me saying x equals negative 1, y equals 6. So f of negative 1 is what this represents. I'm sorry. And then this guy right here represents f of negative 1 equals 6. Okay? So I don't know if that helps put things in perspective, what you're seeing. Okay? And that's it, guys. So that's a lot. We described what a relation is. Okay? What type of relation? Is it discrete or continuous? We also did, is it a one-to-one or onto function? Or maybe it isn't a function at all. Okay, so we discussed that as well. So it's a lot packed into this lesson. So please look over the notes. They'll be online for you to watch or to look over. Okay. But other than that, that's it, guys. That's the start of our next unit. Okay, with functions and relations. So thank you for watching. Hope you're doing well at home. And until next time, have a good day.